Some little bit of introduction. My name is written here, Dr. Saurabh Ranjan Das. Okay, I am a chemistry faculty here for the last 23 years. And here, first of all, I want to clarify one doubt. I am becoming a computer engineer. Why I should study chemistry? Obviously, that question comes to our mind. That why should I study chemistry? Why should I study physics? Because the basic subject, first year, you have to pass through these subjects: physics, chemistry, mathematics, English, and then in the second year you will have biology also. So different subjects you are studying, which maybe you are not very accustomed. You will think that already you have studied this thing in 11, 12, right? So you have studied already, that's true. But still you have to study. Why? Because according to Heisenberg, you have heard the name Heisenberg uncertainty principle? That Heisenberg told that science clears the field on which technology can build. First of all, science background should be very much clear, then only technology can be developed. Do you understand what is the difference between engineering and technology? Some finer aspects, very close, but they are almost same but not same. Technology, some theory and some practical real life experience, both will be combined, that is technology. And engineering is more about the practical problems, dealing with the practical problems, and theory part is less. Okay, and that is the basic difference between that engineering and technology. Now chemistry is science. Now question is, what is the difference, science and engineering? Science gives the invention, technology gives the innovation. Difference between invention and innovation, you understand? Invention, you create, make something. Suddenly in the laboratory you got some experiment found successful. So that is your invention. After that, how you will use it in real life, that is your invention. It is not invention, now it will become innovation. How your different way you can use it to make our life easier, that is called innovation. So innovative ideas you can implement again and again. Very simple thing, I am giving you some example. Well, chlorine water. If you take chlorine water, it is normally colorless. How do you use it? Chlorine water, disinfecting water. If you add a few drops of chlorine into water, that will disinfect. So that is the way we can purify water. Now same thing, this chlorine water, if you can take into a bottle, transparent bottle, plastic bottle maybe, if you take this chlorine water and hang into some room where half it is exposed to sunlight and half it is inside the room, that way if it is kept in the village area where there is no electricity, it can act as a low power bulb. Okay, do you understand what I am telling? That is innovation. It is no invention, it is not research, but practically how you are implementing the idea, that is innovative ideas. You have got some village area, some small cottage, and the rooftop is just tin shed. Now in the tin shed you can make some small holes, and there the bottles are fitted inside half, outside half. Outside is exposed to sunlight and inside is inside the room. And those rooms are usually all very gloomy rooms. Means sufficient light is not there. So this type of this chlorinated water filled these bottles, if you keep that way, it will be illuminated. Somehow some amount of light you will get. Why? Because it has a capacity to absorb and glow. This chlorine water can absorb and glow. That is the idea. It's practical, small things we can use in everyday life. So that is that. Who will be doing that? That is engineering. Okay. Technical ideas you can use here and there. That's small thing I told you, but there are so many others also. Now, that different type of engineering, we have electrical, mechanical, civil. Science applied everywhere. Suppose civil. So what we are using there? Cement. Cement is a very important part of civil engineering. Concrete, making concrete you need cement. But for cement manufacturing, different type of things can be added to improve the quality of the city. So who will do that? That research area is not civil engineering research. Civil engineer will do the concrete, whether it is working good or not. They will just measure the strength of the material, whether the concrete is having a very good strength, how much durability, how much air pocket there inside the concrete. They will deal with that. But civil engineer will not deal with the quality of the cement. That will be dealt by chemist. So chemist will add different admixtures, different materials, and do the research to find out how is the quality of the cement. So that's why there is a nowadays there is a term. It is called multidisciplinary research. Different field area people are combining doing a project, multidisciplinary project. That is becoming more and more popular. So you know that environmental science is a subject. So this environmental science, normally we ignore it. Before the exam we do this for one day, right? You study for one day and then appear exam. So far you have done that, like that. But practically our problem is increasing day by day, the environment related problems. So these, if you really want to deal with the problem, with the solution of the problem, then you have to have different people gathered into under the same umbrella. Different people. So that is multidisciplinary, different subject people should be gathered. Suppose there is a toxic problem, toxicity problem. Some chemical is toxic and it has got a toxicity over a population. So how do you remove the toxicity, or how can you minimize the toxicity, or what is the remedy of that? Who will deal with that? Doctor? If it is having this problem on human, then who will deal with that? Doctor. So doctor will be required. Some machine you will need to purify the air before releasing in the atmosphere. That is called electrostatic precipitator. For before releasing into the atmosphere, the gas mixture, you purify the gas mixture by removing dust particle and all. So what is the machine called? Electrostatic precipitator. So who will deal with this type of machines? Who will make this type of machines? Engineers. What? Which engineer? कौन बनाएगा मशीन इस टाइप का? Electronics and instrumentation, EIE. So all different subjects are involved. So that is multidisciplinary. Okay, so now application part, if you go, definition scope of chemistry and engineering, as I told civil engineering. Now let's come to computer science. So many of you are becoming computer engineer. So for computer engineering, hardware is necessary. Without hardware, your software cannot work, right? So this is my hardware, and here whatever I am doing is the software. So that hardware, how it is made? Plastics, different type of plastics, and there are other things also. There will be liquid crystal, the screen, LCD, liquid crystal, and then inside the what do you have? My different chips. And what is the one major component of computer? That is silicon. So where from you get the silicon? Where from you get the silicon? We buy it, no doubt, but who is that seller? How do you make it? Someone will manufacture, na? How will you make it? What is the source of silicon? Any idea? Source of silicon? Sand, silica, SiO2. But it is SiO2 and Si are not same. Difficult to take out the silicon from silica, because silica itself is a very, very stable compound. It is very stable compound. You cannot break SiO2 so easily. So that means it is you need lot of attention there. It's not so easy to make out. Okay, so this is one. So what is the, from my discussion, what is the main important part of chemistry into engineering? Can you make out of this so many discussions? Can you make out what is the major important part of chemistry in engineering? No idea? Could not understand? एक particular word से बताओ. Materials, make it general. For materials, you have to depend on chemistry. Without chemistry, you cannot get materials. So, material science is a part of chemistry, material science. So that's a few years back. so far I remember, maybe 7-8 years back, there was a subject, material science, in the electrical engineering course, and it was taken by chemistry department. Nowadays it is taking, they are taking, means department itself taking, but actually it is a branch of chemistry, material science, different type of materials. What is the major material that we deal with? Metal and polymer. One is metal, other one is polymer, and sometimes blend, polymer mixer. So main these two things, metal and polymer. Now metallurgy. There is a lot of chemistry involved in metallurgy. Okay. So what is the basic difference between some science and engineering? Science is dealing with, means laboratory, dealing with a few grams of materials. And in the chemistry and chemical engineering, actually I have both the fields. I have chemistry background as well as chemical engineering background. I did chemistry MSc from IIT Kharagpur and did my PhD in chemical engineering from IIT Bombay. So that's why both background I have, and I can very clearly explain you what is the basic difference. So chemistry, what you do? Chemistry, we are dealing with a few grams of materials or chemicals. So because it is research, we need milligram, microgram for analysis. So if I make 10 gram is good enough for me, for all analysis, good enough. And nowadays analytical instruments are so sophisticated. If you give a more than 2 microliter, machine will be so out of range. It will so out of range. That means you will have to reduce the quantity. Very, very small quantity, minute quantity required for analysis. Okay, that instrument I have, I can show you someday. Okay, so this is analytical instruments. These are very, very sophisticated and it's very small, minute quantity required. So how much quantity I need? 10 gram, make enough for my analysis. But for chemical engineer, we will need a chemical process principle analysis. Chemical industry. So what is the setup? It will have to make some engineering design, machine design, and there we are dealing with a few kg. That is called pilot scale. And this phenomena from few grams to few kg, it is called scale up. Scale up. Because earlier I was dealing with gram, now I am dealing with kilogram. So that scale up is done and it is called pilot plant. And after that, in the main industry, the manufacturing industry, there we are dealing with tons. So from few kg to few tons. Okay. So whatever mistake you do, whatever trial and error you do, that you have to do with few grams only. After that, when you are satisfied with the result, you can go for a few kg. If it is successful, then only you can go for a ton. Because there is a difference. When you take a few grams into a beaker, a bodyker, and do the mixing, you can do it by hand. Very nicely, you just give the movement like this and you are doing the titration. So it can be done. But if you are dealing with a few kg, this will not be possible. Then what type of mixing for blender? So, some sort of stirrer, some motor stirrer, some magnetic stirrer will be required. Now if you go for a larger scale, then even this type of system will not work. You have to have a system, very long apparatus, and there are multiple stages the blending or mixing must be done. Then also there may be some trouble. Sometimes it happens, particularly polymerization reaction. If you take some monomer and blend it, polymerization gets started. Okay, sometimes little bit of polymerization may start. So if it gets started, then solidification gets starts. And if solidification is occurring, then mixing will be very difficult. It is becoming very viscous, highly viscous. Then if it is a viscous one, your rotor or motor may not have enough power to thoroughly mix it. Maybe it will stop functioning. The motor stop functioning because already solidification is started. So you have to have a proper planning for that. That's the problem. Otherwise, maybe in the middle of the reaction itself, the solidification gets started and totally it is becoming a useless junk. It will be totally thrown useless and loss to the company. So minimum the basic knowledge or idea you required. So that's why scale up is required. First a few gram, then kilogram, then ton. So what are the industries particularly? So one by one I can explain you. Like mechanical engineering, there we have as example I can take car. Okay, CI engine and SI engine. That petrol car and diesel car. Petrol car is cheaper, diesel car is costlier, and diesel efficiency is more than petrol. Can you tell me why? Why diesel efficiency is more than petrol? Any idea? पेट्रोल एफिशिएंसी कम क्यों है, डीजल का एफिशिएंसी ज़्यादा क्यों है? एफिशिएंसी मीन्स माइलेज पर किलोमीटर, पर लीटर हाउ मेनी किलोमीटर इट कैन रन, दैट इज कॉल्ड द माइलेज. So mileage of petrol is less compared to mileage of diesel. Why? Because the diesel chain molecule is longer. Do you have any idea what is the composition of petrol diesel or not? Petrol diesel, what is the composition, chemical composition? Any idea? पता नहीं. अच्छा, petrol, the composition is pentane, hexane, heptane, octane, pentene, hexene, heptene, octane. I think these names are familiar to you. Pentane, hexane, heptane, octane, pentene, hexene, heptane, octane. So alkanes are 75%, alkenes are around 25%. That's the composition. Got it? So this is petrol. And what is diesel? Pentadecane to octadecane and pentadecane to octadecane. What is the meaning? Petrol 5 से 8, diesel 15 से 18. Is it clear now? Carbon number 5 to 8 petrol and carbon number 15 to 18 diesel. Got the difference? So longer chain, hydrocarbon, both are hydrocarbon but longer chain. In case of petrol, smaller chain, for diesel longer chain, very much longer. It is 5 to 8 and it is 15 to 80, very long chain. So this long chain, if you burn, you get more energy. That's why same quantity of diesel will produce more energy compared to petrol. That is the reason. But why it is then always not used? Because petrol had got certain advantage also. It is much more smooth function compared to diesel. Diesel engine is giving some more vibration compared to petrol engine. So petrol is much more smooth compared to diesel. So this type of basic difference, who will analyze and do this type of research? That is chemistry. Fundamental role of chemistry in material engineering. Number 1, chemical composition influences the material properties. You can go through, already it is written. Innovation through chemical processes. These things are chemistry in industry. How we are working, chemistry is working into industry. Now, role of chemistry in chemical engineering, process design, kinetics in, I am just reading the headlines, things are already written, I need not read it for you, you can read yourself. So now for example, catalyst. What is catalyst? Catalysis, one important portion of chemistry that is used into industry, catalysis. What is the importance of catalyst? I will tell you. If you do some reaction, you have to supply some energy, that is called activation energy, then to perform the reaction. Without activation energy, no reaction cannot happen. Now with catalyst, the activation energy can be reduced. Okay, catalyst डालेंगे तो activation energy नीचे आ जाता है. पता है क्यों? That catalyst participate in the reaction in such a way, ultimately it comes back, maybe in the original form or may not be in the original form, but it comes back always. That is called catalyst. Sometimes we can reuse it, sometimes we can regenerate, but sometimes we cannot. You have to throw it. Okay, but always we will try to use whenever possible, because that will give the economy of the process. Now, what I am giving you an example. Suppose this is a platinum plate. Now I have given some hydrogen gas in presence of platinum. So what will happen? Platinum has a tendency, surface energy is very high on the surface of the platinum or any metal like that. Surface energy is very high and it will attract the hydrogen gas and it will stick to the surface of the platinum. Attract करके उसके ऊपर वो बैठ जाए. So that is called chemisorption. chemical adsorption or chemisorption. So hydrogen gas will be atomized first. वो फर्स्ट एटोमाइज होगा, उसके बाद वो मेटल सरफेस के ऊपर स्टिक करेगा, मतलब चिपक जाएगा. एटोमाइज होने के बाद चिपक जाएगा. कैन यू टेल मी व्हाई? ऐसा क्यों होता है? बिकॉज इन द बल्क प्लैटिनम का वैलेंसी क्या है? नो आइडिया? 4. प्लैटिनम का वैलेंसी है 4. तो कितना बॉन्ड करेगा वो? 4. तो बल्क के अंदर 4 बॉन्ड कर रहा है. व्हाट अबाउट सरफेस? जो सरफेस का ऊपर है उसके पास 4 एटम मिलेगा कहाँ? तीनों साइड में मिलेगा, ऊपर तो कोई है नहीं. वुड यू अंडरस्टैंड व्हाट आई एम टेलिंग? इधर प्लैटिनम है, इधर भी है, बाहर तो नहीं है. तो जो सरफेस के ऊपर है वो बाहर से उसको चौथा वाला कहाँ मिलेगा? नहीं मिलेगा. तो मतलब 1 वैलेंसी विल बी डिससैटिस्फाइड, 3 वैलेंसी सेटिस्फाइड, बट चौथा वाला नॉट सेटिस्फाइड, 4th one is not satisfied. Is clear? So that's why it has got a extra energy on the surface. If it is not stable, then what happens? Higher energy. That's why the extra surface energy will be generated. Why? The molecules are not getting satisfied. Satisfaction नहीं होगा तो energize होगा. तो molecules are not satisfied. That's why energized on the surface. That is called surface energy. समझा कि नहीं? Now molecules of hydrogen getting atomized and getting attached to the surface because the 4th valency was not satisfied. So it will stick to the surface. Whenever ethylene gas comes in contact, it will release the hydrogen because it will also pull. And due to this pull, the hydrogen comes out and gets attached to the ethylene, giving ethane. So ethylene hydrogenation, do you remember? CH2 double bond CH2 arrow, H2 nickel, right hand side CH3. Just think, 11 12 में पढ़ा ना? CH2 double bond CH2 arrow, H2 slash Ni, right hand side CH3. What is this called? Hydrogenation of ethylene. Simple example I am telling you. Hydrogenation of ethylene. So how it is happening? This is the way. First of all, the nickel or platinum, whatever metal we are taking, both are tetravalent. Nickel is also tetravalent, platinum is tetravalent. So hydrogen is getting atomized, getting stick to the surface. On the surface of the platinum or nickel getting attached. And whenever ethylene gas coming in contact, hydrogen is supplied from one side. So it is called cis hydrogenation. By this cis hydrogenation process, ethylene is getting hydrogenated, giving you ethane. So hydrogenation is reaction. So this way, isn't it becoming easier? Because earlier H2 you have to break into H. Now you don't need to break. Already broken. Broken by the surface energy of the nickel itself. So you don't have to supply energy. So activation energy will come down. So that is the role of catalyst. So catalysis, as I told, so this is the role of the catalyst. Okay, regarding water, I want why I keep PowerPoint in front of me? Because I get the points, nothing else. PowerPoint. So I am getting the points and then discuss. I don't need to read. You read yourself whenever required. Now, water, regarding water I want to talk about. So, drinking water, very important for us, for our health, for everything. So this drinking water purification is necessary, otherwise we will become sick. So how do you do it? By aquaguard. Achha, now you need to understand what is there in aquaguard. If you understand the principles of machines, then you can have a better decision to buy the machine. Whether this machine is good for me or this one is better for me, you will understand. That's why the inside mechanism of every machine you should understand. So some basic idea it is, not the whole, always. Okay, so aquaguard I will clarify. 3 chambers are there. One chamber, it is filtering the water by some cloth, like just like cloth filter, kapda se chante hai na pani. So similarly here you have thread, tightly spiral thread is there, forming like a cloth. Now when water is passing through that, the dust particle or dirt particle will be captured. So water is getting filtered. First chamber. Second chamber, there is another one. There you have activated charcoal. What is the role? It will absorb the undesirable smell, color from the water. होता है ना पानी में कभी कभी थोड़ा स्मेल आता है, तो that can be removed by this activated charcoal, because activated charcoal has a tendency to absorb color and smell. So that is done. What left? What is left now? Pathogenic bacteria that you need to remove. Otherwise, again you become sick. So this pathogenic bacteria we have. An example like this. Suppose this one is a pathogenic bacteria. What is these hairs called? Cilia, right? Achha, now here we have DNA. Our DNA is alpha helix. Our DNA is called alpha helix, human, Homo sapiens. But here this bacterial DNA, they are mostly that is called strand DNA. Means straight forward, straight type, rod type, strand. Now if we expose ultraviolet by some lamp, ultraviolet lamp is there, UV lamp. By this UV lamp, if we irradiate the ultraviolet radiation, then what will happen? This will break in the middle. The DNA will be ruptured and bacterial growth will be hindered. And the main problem is growth. Anywhere, just inoculate with a bacterial, with a needle. You take fresh water and with needle you inoculate the bacteria into the fresh water. Within an hour, not few, within an hour you will find millions of bacteria. So that growth is the main trouble. That's why we cannot cope up. This much of growth we cannot handle, our body cannot handle. इतना ज़्यादा growth होगा तो उसको मारना मुश्किल है, right? So that growth is hindered because the DNA is ruptured and they cannot do their normal functioning. So growth is ruptured. So cell breaking the cell into multiple number of bacteria, that is cell division. That part is hindered because DNA is not functioning. So that way it will be stupefied for 24 hours. Particular term I call it stupefaction. So they are stupefied for 24 hours. Okay. So that means they will have no normal functioning for the 24 hours. If it is kept in the sunlight, then they will recover after 24 hours. But if it is kept, the water is kept under dark condition, it can be safe for drinking for 2 days. And if you keep it in the refrigerator, it can be kept for 3 days safe. Safely you can drink the water for 3 days. What are you doing? Mobile. Look at me. Eye contact is very important. Okay, for every student. Eye contact is very important. Otherwise I will have a doubt. Okay, so could you understand AquaGuard principle? So this is AquaGuard principle, basic principle. Another method is there apart from AquaGuard, that is called ozonization. I will tell you all the methods. Now you decide which one is better. That is up to you. You will decide which one is better. Another method is called ozonization. That is benefit is it is very much portable. You can carry that instrument like a pen. Just like we can carry the pen always, we can carry this also, this electrode also with us. Suppose you have gone into some hotel, so and you don't have any mineral water not available in that hotel because it is roadside dhaba and mineral water bottle is not available. Mostly it is available, but by chance it is not available. So they are giving normal water, but you are very eager to drink because you are feeling very thirsty. Then what you will do? Situation is very bad. So in that case, what you can do, if you carry the pen with you, you can just open, means pen, not pen, this pen. That pen is called, that is a sort of electrode. It has got cathode and anode and battery driven, and their electrodes are made of silver electrodes. Switch on, it will give some vibration and some electrolysis will take place. Put into the water, it will give some electrolysis. Ozonized oxygen will be generated and it will kill the bacteria. And it will be safe for drinking. Just 2 minutes you dip into one glass, take it out and it will be safe for drinking. Rechargeable. Isn't it good idea? But the problem of ozonization is that it is for emergency we are using, fine. But problem of ozonation is that we are killing the bacteria, rupturing their cell wall, and that is not a very good idea. Because if you rupture the cell wall of the bacteria, the shape from inside, the cytoplasm, I think, that comes out and mix up with the water, and that is not very desirable to drink, isn't it? बैक्टीरिया को अगर निकाल दे तो अच्छा है ना, उसको तोड़ के फोड़ के पीने का क्या मतलब, ठीक नहीं? तो that is the problem of this ozonation. There is another one called reverse osmosis. Reverse osmosis, what? Do you understand osmosis? Osmosis is a technique. First, osmosis is very natural. Like if you take a handful of resin, resin, kismis, put into water, then overnight, then in the morning, what do you see? They are becoming they are soiling. They are soiling, and the water has gone inside. They have already soiled, right? So that is called end osmosis. Water percolated inside. Sometimes that opposite action also may take place. If you take a very concentrated salt solution and put something in that grapes if you put into that, maybe the water will come out from the grapes and it will sink. So that is called exosmosis. The solvent has come out. So this is a natural process. Now, this concept we are using into reverse osmosis in the opposite way. You have two chambers. Look at it. You have a container like this, and in between you have a semi-permeable membrane. This is the semi-permeable membrane, and here we have a solution. This side also you have a solution. Here concentration C1, here concentration C2, and C1 has a higher concentration than C2. C1 has a higher concentration than C2. Now tell me, in normal condition, which side the water will flow? Both are aqueous solution, same solution, maybe copper sulfate solution, both sides. More concentration, less concentration. Which direction water will flow? From C1 to C2. C1 more concentration, C2 less concentration. It will become C2 to C1. Movement will be always from C2 to C1. Means lower concentration towards higher concentration side. Why it is happening? Because chemical potential. This phenomenon is called chemical potential. Because of higher chemical concentration, higher chemical potential, higher free energy, and that's what is happening. Thermodynamics, when you study, you will understand. Okay, free energy. Now, free energy per mole is called chemical potential. Because of that, higher concentration, higher free energy, higher chemical potential, the movement will be opposite direction. So, to make the free energy equal, higher free energy, lower free energy, so they want to try to make the balance. That is a natural tendency. Always everything want to get balanced itself. So it is getting balanced. So water is moving this direction. That is called osmosis. Now if you apply pressure here, this side, higher pressure if you apply, it may happen the solvent is moving in the opposite direction. That is called reverse osmosis. Okay. And that principle we are applying in so many fields. You have heard about Amul Tetra Pak milk? वो जो बक्सा आता है अमूल टेट्रा पैक, that is available mostly into all shopping malls. Amul Tetra Pak box. Okay, there are 4 layers. That's why Tetra Pak. Now this milk is highly concentrated. That's why they can travel from Gujarat to Bengal without any the problem. Means it is not getting denatured. दूध फटता नहीं. Why? Because highly concentrated, and in a highly concentrated situation, bacteria cannot grow. उसको concentrate बना देंगे तो bacteria growth नहीं होता. This is true for any food, pickles, any type of food. Bacteria will not grow where concentration is very high. It will take very long time to degrade. But if it is a dilute one, bacteria can easily grow, and it can adulterate the material very fast. So these are some some application. Mechanical engineering, corrosion is very related to chemistry. So everywhere this for corrosion protection, lot of research already. It is a very old field. Lot of research happened and still happening. So there is a MTech degree also on corrosion. MTech in corrosion science. Okay. So NIT Durgapur had this degree, MTech in corrosion. Now there is MSc in corrosion. So this type of things there. Corrosion means what? Natural wear and tear. Natural wear and tear. It is called. That slowly getting degraded. The materials are slowly getting degraded. So a piece of iron, if you keep in the open air, maybe in the rooftop, how many years it will last? It will be rusted. First it will become rusted, and then highly corroded, and then you will find one fine morning it is broken into two pieces. So that is a natural wear and tear. So that is corrosion. So if you want to protect from it, from corrosion, you have to give some coating. What type of coating? Different types of coating can be available. One is called galvanization. You also tell what type of coating? Painting. Ordinary painting. पेंट कर देंगे ना. ग्रिल को क्या करते हैं? पेंटिंग. अच्छा, और क्या कर सकते हैं? पीच लगा देते हैं. ब्लैक कलर अलकातरा लगा देते हैं. टीना के ऊपर क्या करते हैं? अलकातरा लगाते हैं. और क्या कर सकते हैं? डिफरेंट वेज, मेथड्स एंड टेक्निक. अच्छा, गैल्वेनाइजेशन कर सकते हैं, मतलब दैट इज जिंक प्लेटिंग. टीन प्लेटिंग कर सकते हैं. अच्छा, गैल्वेनाइज करेंगे तो कोटिंग जो है, coating, the zinc coating, that is getting degraded, but inside metal is intact. But if you go for tin plating, tin surface, ऊपर surface में tin तो ठीक रहेगा, अंदर आयरन कहीं भी स्क्रैच होगा तो आयरन धीरे धीरे अंदर डिग्रेड हो रहा है, बाहर से पता नहीं चलेगा. That is the problem. Okay, so different type of such coatings are there. Aluminium can be, we can make aluminium nitride. We can take iron nitride. Okay, this type of coating can be made. It is called calorizing. By heating iron and nitrogen, reaction we can do by high temperature nitrogen, passing high temperature nitrogen onto iron. We can make aluminium nitride, ALN. We can make iron nitride, Fe. What is the formula? Iron and nitride, FeN, ferric and nitrogen. FeN. So this type of different coating we can make. Achha, aluminium normally don't need any coating. Can you tell me why? Aluminium corrosion normally hota nahi hai zyada. Aluminium. Why? Because it makes its coating itself. That is aluminium oxide, alumina. The alumina in presence of water, if you just sprinkle some water and leave it that way, it becomes oxide on the surface. And that's why it will become dull. The lustrous nature of the aluminium sheet will go within a very short time, and after that it will be protected. Further corrosion will not happen because the surface is already coated with aluminium oxide. So it is self protection. Achha. So just go through first line at least to read. Electrical engineering, that is polymers. Polymers applied in every field, even in computer making. Battery industry, battery. Okay, different type of battery. We have a huge necessity nowadays. We are using huge number of batteries. Always. तुम्हारे पास बैटरी है अभी? हाँ? नहीं है? मोबाइल नहीं है? तो उसके अंदर बैटरी है ना? खा गया ना धोखा? है ना बैटरी तुम्हारे पास? सबके पास बैटरी है, क्योंकि सबके पास मोबाइल है. So that I wanted to tell you. Without battery, you cannot, nowadays you cannot, your civilization will be totally stopped. Not possible without battery. And battery, how do you get from, what is the most important material of your battery, of this mobile battery? Lithium. And that is the most precious metal. This lithium is not made. Lithium cannot be made. समझे क्या बोल रहा नहीं? लिथियम बना नहीं सकते तुम, वो बन चुका है स्पेस में, कॉस्मोस में बना चुका था. यू कैनॉट मेक इट, मीन्स ह्यूमन कैनॉट मेक इट. ओके, सो दैट्स व्हाई इट इज वेरी वेरी रेयर मटेरियल. Lithium, this, what is the atomic number? 3. So 3 atomic number means odd atomic number is very rare in the nature. Even number you will get very frequent, but odd number is rather rare. Okay, that is the natural selection rule you find everywhere. Even is very common, odd is rare. So this lithium is really a odd atomic number, and it is really odd element because it made by itself, you cannot make it. Now concrete, already told you in the concrete already. Soil, civil engineering, cement, concrete, soil testing, सब chemistry. Nanotechnology, that is a new technology coming up nowadays, but it is found that this was there in the pyramid also. So how many years old pyramid? Middle era, na? So that pyramid, inside the pyramid also, we got some evidence that there is a use of nanotechnology that time. That means already forgot the technology and we are reinventing it. हम लोग बनाए थे, भूल चुके थे, फिर से बना रहे हैं, फिर से वो नैनो टेक्नोलॉजी को ला रहे हैं. What is nano? Nano is 10 to the -9, very small size. 10 to the -9 meter is called nanometer, and 1 to 100 nanometer range where we can call it a nano scale, nano size material. What is the beauty of the system? I will tell you. Any macro material, classical mechanics is applicable, but very small micro material like nanomaterial and quantum mechanics is applicable. So this nanomaterial is actually in between the classical mechanics and quantum mechanics domain. It is just in the threshold. उसका size ऐसा है कि वो classical mechanics और quantum mechanics का बीच में खड़ा है. Isn't it nice? इसलिए क्या होता है, उसको हम लोग प्रॉपरली यूज कर पाएंगे तो बहुत कुछ नया, टोटली न्यू डोमेन कैन बी टोटल एक्सप्लोर, ए न्यू डोमेन कैन बी एक्सप्लोर. Okay, now attendance. Just one sec.